we'll get started with C programming for Arduino. So this is just a little bit introduction into what we are going to do in this presentation. So I'm just going to give you an overview of C and also explain you some of the major concepts that we will encounter. So C is just a general purpose compiler programming language which was initially developed by Dennis Ritchie. So you might have known Dennis Ritchie from the very famous book of his, and so that's about, in that book he has given everything that you need to know about C programming, what it is, etc. So the C language is widely used for programming in hardware devices and also finds its general purpose use in applications, programming language, tools, and operating systems. So even we have learned quite a bit of C in our very initial semesters that we have seen, and we are still going to, in this we are just going to brush up all those concepts that we have learned in our first semester and try applying them, and this would form the basis or the fundamentals of when you would enter into the world of Arduino. So in this slide I've just introduced you to C programming. So in order to run C programs you will need a programming editor or IDE. So in our case we are using the Visual Studio Community Edition. So this is the Visual Studio Community Edition, and we will be using this in order to basically realize or work with C programming. And IDE stands for Integrated Development Environment. So IDE gives you the special features of debugging or doing a lot of things. So when you explore these menu tabs, you can do a lot of things. These taskbars and toolbars, you can do a lot of things. And this is slightly different because when you basically code in a command line prompt, all you have to do is you have to manually type all the commands, and you also have to invoke the compiler by writing GCC, the specific compiler. But in C programming, when you have an IDE, all that process is much simpler, and you can start debugging your programs quite easily. Once you have a C compiler and a C source code ready and installed, you can get started in programming with C. So generally for C programming, so once you have an IDE, for example, CodeLight is an IDE, is an alternative IDE for coding in C. So if you install CodeLight in your computer, you also have to make sure that you are installing something called as a compiler. So this compiler will also help in basically compiling your C programs, and this compiler is basically when you take into command line when you take command line into consideration, the command is GCC. So there are many compilers which are available in order to accomplish this task. So C compilers are made available for all major operating systems that are available, that include Windows or OS X and Linux. So moving on, so this is our IDE, and for this we would use Visual Studio Code. Now in this slide, I'm just going to explain how C programs are compiled. So it's a three-step process. First, as you can see, you have a C file. So this C file is basically written in higher language, which the machine can't understand. All the machine understands is the binary language. We have three files here called a1.c, a2.c, and a3.c, and in each of these C files we have functions f1, we have functions f2, and also we have a main. What happens is these three files are basically going through something called a compiler, and this compiler basically does the job of converting one .c file into an object file. So that's the use of this compiler. It basically converts the .c files into object files, and now even in object files are also not executable, so you need something called a linker. So this linker basically converts these objects files, that is a1.object, a2.object, and a3.object, into executable files. So this is one of the very important uh, things that you need to consider when you are compiling the C programs. This is the overview of how exactly a C compiler basically compiles a .c file into something called as an executable file, and then the output is basically written on the screen. So this is the complete process. Moving on, we are jumping into the programming with the C language. So in any language, when you take for example the first lines or the first few lines of code that we write are hash include stdio.h, and we have a main function, and in this main function what we do is we print whatever the desired output that we want to print, like for example hello world, or whatever statement or strings that we want to enter. Now we will be looking at each of these and what it means. So when you look it from the outside, it looks quite complex, but we'll also anyhow refresh what we have learned in C for the first in initial days. So in the initial days it used to be like this. So this hash include is a preprocessor directive. So what happens is that there it searches for a particular file called stdio.io.h, and basically causes the contents of this header file to be included, because in this header file we have a lot of precious information about what needs to be done. So you have this angled brackets here. So the angled brackets tells to search for the file. So as I told earlier, so this stdio.h is being searched, and that stdio.h would be outputted. So here in the main function we are just writing print hello world. So main is the name of the function that it's where the program starts in C basically. So printf is a function in stdio.h. So as I told sometime earlier, that stdio.h has some contents which are basically present, and printf is one such function. And hello world is a string of characters that is passed, and slash n is basically an escape character, and this prints a new line. So moving on. So this is about the introduction. As I told, stdio.h is a system-wide C file that is supplied to the compiler, and it is used in most of the programs. It provides a number of functions. So this is the preprocessor. As we have seen, what's the preprocessor directive over here? So this statement here, hash include stdio.h, forms the preprocessor directive, and it basically what it does is every C program has a main function, as we have just discussed, and it's the place where the program begins. The curly brackets basically mark the blocks of code. So you are writing some kind of business logic, and that business logic is basically entered into this curly brackets. So this is interesting. So sometimes we might also have arguments and return types. Not in all the IDs. Suppose if you take CodeLight for example, and you when you create a new project, what happens is that you are also this also enters. So there is the main function. The main function before the main function int is preceded, and there are two arguments over here. One argument is argc and the other argument is argv. Basically what this argv does is, argv is a character or a vector of C strings. So int argc and char double star argv. So here is where something called as pointer gets in. So we are not going to discuss about pointer concepts here. It's slightly out of the scope for when you discuss Arduino programming. But here what happens is that you are basically printing hello world over here, and here we will be looking at what is the use of argc and what is the use of star star argv. The first argument argc is which the input or bits of data that has been sent through the program. So instead of just discussing this, we will also be taking a look at how exactly this is being performed. So when you take project one, I'm just making this project one and setting it as a startup project. So in this way you can basically this when you run the file, exactly project one would run. I have many projects under this called solution, so I have made few of the projects over here. So the first statement is hash include stdio.h, and this is the main function. So as we all know, this is very simple to understand. It just prints hello world. We'll be anyhow just taking a look at how to run programs using Visual Studio. So when you just click the play button, the output appears on the screen. So as you can see, hello world has been the output, and the output is correct as we guessed. So here what happens is that this is slightly different. Also, when the slash star and star slash is basically multi-line comments, so you can enter multi-line comments, you can start a multi-line comment and also enter a enter and you can also conclude the multi-line comment by pressing the star slash button. So what happens is that the code which is below under this slash star and star slash is basically commented off. That means when the file is running, it just tells the compiler not to include the lines which are commented off or which are in green. So here what happens is that in this argv, in the presentation we have seen that argv is a character argv character is a vector of C string. So here we would actually see what is being stored in this argv and what is being stored in this argc. So we are just printing argc is equal to percentage %d argc, and we are also seeing what is present inside this argv by just writing down that argv and in square brackets I. So we are just seeing what is in that. So when we run, and also another point that I would like to discuss is that before main int is being preceded, which means that this function main has to return some kind of integer value. So that is being returned here. That's why this return statement is written. So as you can see, argc is 1 and arg0 is the address of the file where this project 1.exe is basically stored. So this file has gone through the .c from the higher language which was present over here. It has been converted and converted again into executable file in the last step, as we have discussed in the earlier PPT. So here this is the Visual Studio debug console, and here what happens is that in the string of characters, what is being output is arg0. So arg here 0 is being 0 is outputted. So here in argv 0, so here what exactly is outputted is, you can see that in the C drive and exactly where this project location is that is being outputted. So that is the use of RV. Here we see that, but in Linux you might see something slightly different. So that's about argc and argv and the discussion. So in this PPT, just to wrap up, there can be arguments to a function which can be passed, and there are also return values. A function basically has to return, this function has to return a number 0 because there's the keyword int which is being preceded, which is written just before the main. So that's the use of the arguments and return values in this case. Now we'll look at data types and variables. So in C, the variable is declared by stating its data type followed by the name of a particular name of a variable name. So this data type helps in specifying the type of data a particular variable can store. So in variables are quite common even in other programming languages, for say for example JavaScript. So variable is nothing but a container of a value. So it stores something that we want to enter into this variable, and that can be used in anywhere else in the program instead of typing the same thing again and again at different places. So you can invent the names of your variables as a general rule, and it is best to keep the variable name descriptive. This means that whenever you are initializing variables, it is better practice to basically give some kind of name which that particular variable would do. So in the code when you write, you know that this variable has to perform this function. So when you give it a similar name to that function, so that action that you want to perform, uh, what happens is that it is easy for you to basically find out or point to that variable. So the name of the variables is composed of letters, digits, and underscore character. An important point to consider here is that it must begin with a letter or an underscore. That's very important over here. It cannot begin with a number. Like we can say we can initialize a variable like n1, but we can't initialize a variable like 1n. So that is one important point that you need to consider when you are uh, talking about data types and variables and initializing the data types and variables. Now, in the next slide, we move to some of the rules for declaration of variables in C. So, a variable name can have letters. It can be both uppercase and lowercase. And as we discussed in the previous slide, one important thing to consider is that whenever there is a variable, it has to start with a particular alphabet, or it can't start with a number. So that's what the second point says. The first letter of the variable could be an underscore or a letter, but it can't be a number. Variables can be declared of any length. Okay, so but here there also is a small point to consider, and that is we have to make sure that the length of the variable is not more than 31 characters. And I think it's fairly reasonable to say 31 should be, if you are actually creating a variable which is of more than 31 characters, it wouldn't make that much sense to. So the variable would be too long and it would be too descriptive and wordy. And the next point says is C is a very strongly typed language. This means that the type of variable cannot be changed once it is being declared. So that's the point over here. So the next point says that it is always better to give meaningful variable names so that it improves the readability of the code. So this was the same point I was stressing on in the last presentation. So last slide. So it is better always to give a particular variable name, and when you are assigning that variable some number, you know what the number is going to do. That is why you have initialized that variable, and even you know what that variable is going to perform. So it is always better to give a meaningful name to such variables in order to increase the code readability. So we'll be moving on. So this is a schematic diagram of the variables in C that we have. So we have data types. Basically, they are basic data types, derived data types, enumeration data types, and void data types. When you put void before a function, when void word is preceded before a function, it means that nothing is outputted. So we are not actually returning anything, something like the int or char, for example. So these are some of the basic types that include char, int, float, and double. Now in the next slide, we just have a very easy to understand example program, and this program basically talks about all the different kinds of variables that we have mentioned until now, and one among them is being int. So int tax, int total, int grand total, and double, as we know, is basically coming into play when we have decimal numbers, when we consider decimal numbers. And GST, basically we have, it is just a tax app that we are calculating, and once the total is present, we are actually calculating the tax amount, and then we are calculating the grand total, which is the sum of tax and the total amounts, and we are printing the grand total in the uh, final printf statement. So this is also quite simple to understand. Here what happens is that we have given the value of 500 and we have assigned it to the variable called total. Here we have GST, a variable, and we have assigned it the value 0.75. So here what happens is that the tax is calculated, and we are also making sure that tax is an integer value. So basically after this multiplication, tax would be a integer value, and now the grand total is basically the sum of tax and the total amount that we get, that is 500 plus whatever we get as the multiplication of these two variables, that is GST and total, and now these both are summed together and it is stored in grand total. So this is what this program does. Moving on, now we move on to something called functions. So functions are basically those which divide the code so that each code basically deals with a specific task. In olden days, what used to happen is that there used to be lot of lines of code and it used to be very difficult for us to even debug the code, because when you're debugging code, you might have to see through a lot of lines. Probably in the real world applications, when you consider, there might be 10,000 or 20,000 lines that you might have to debug, and it is not so easy to debug because in those 20,000 lines also there would be many functionalities which are being repeated again and again, and you don't want the repeated functionalities to be again present. So in order, so because of that reason you are writing something called as functions, and debugging can be done one function at a time. And the other biggest advantage of function is that it is reusable. So as we just discussed, in those 10,000 lines also there might be a lot of lines where you might want to reuse some basic particular block of code. So that can be done very easily because of functions, and the function name is preceded by its return value. So every function that we write, we need to also basically describe what it's going to do. Is it going to return an int, or is it going to return some character, or it's not going to return anything. So as we have discussed in the previous PPT, that it has to also be a void. So when there is a void keyword, void word which is written before a function, it means that it's not, nothing is returned by the function. So after the function name we can put a pair of parentheses. So the round brackets and the curly brackets are quite different. What happens is that in the round brackets we actually have two parameters, or two or more parameters also can be entered by the programmer. So here in those round curly braces, what we are going to do is we are just going to enter the number of parameters that the programmer entered, and in the curly brackets or below the curly brackets, what's going to happen is the code block is going to be written by the programmer. So that means in below the flower braces, the particular business logic of the programmer is going to settle in those curly braces. So we'll look at how functions work also. So in this project called functions, we have a file called functions.c, and in this function I have basically included all the different kinds of functions that are possible. So now when you look at say hello function, what it does is it basically prints hello. It just prints hello, but it's not about the simple printing that we are doing here. The ultimate goal of this C tutorial is to understand these keywords and also understand how exactly these functions work and how they are useful in when it comes to implementing them in Arduino. So if you want to create those circuits, you need to know some very important concepts over here. And the first line says hash include stdio.h, that we have already seen, that's the preprocessor, and stdio.h is that header file. So those angle bracket means it's going to look for that file. And now in the second line we have void say hello. So here the say hello function is being, after the say hello function there is the round brackets, and before the say hello function is the void keyword. This means that this say hello is not going to return anything, but inside the code block we have printf, and whatever value is being passed into this printf, that is going to be visible on the console. Now on the second function when we go, this is slightly different. In this function we have a function called greet, and this function greet also basically returns a void, so nothing is returned by this function. And here we are actually passing something called as input parameters. So the parameters are passed inside the round brackets of this function. So when you take up what is being passed inside, it's a char, and it's actually a array. So when you look at the main function, you are actually going to assign something, and that is going to sit in this jar, a name. And in the code block, what you're doing is you're actually accessing that a name, and you're saying it to print whatever is being stored there over here. So this is the way you are going to ask for how whatever is being stored inside this a name is going to be printed over here. So that's about this seventh line of code. Moving on, we have the add function. So over here what happens is that it's again an integer type, so this means that it has to return. This is slightly different from the other first two functions that we have seen, which only returns void. That means it returns nothing. And here we have an int keyword written, so it has to basically return a integer value, and this function has to return a float value. And the name of this function is add, so it basically returns num1 plus num2, and these two are the input parameters. The first one is called the num1, and that is also an integer, and the second parameter we have, and that's also an integer. So basically this add function returns num1 plus num2, and whatever is the result of num1 plus num2, it basically returns it over here. So we are catching that, and we are putting it into another variable called sum. We have initialized this sum over here. And now moving on to the 13th line of code, we have a function called divide, and this function is basically preceding this function we have float. And basically again the input parameters, we have two parameters, and it takes int parameters, and it returns the division value. Whatever is returned over here, we are again catching it into a place called result, and basically we are dividing these two numbers over here using this divide function. So it's now I think we have got an understanding about what each and every function does. And this is the code block which is present under the main function. Now we can just run this piece of code, or run this functions.c file, and see what is the output. So I'll just make function as the startup project, so that since there are many projects, I would just initialize this as the function startup project, because I would then tell the compiler to run only this project. So this project is functions, and now when I run it, as we have expected, all the output is being displayed over here. Hello Rakshit, sum is 9, and all the output that we needed has been displayed. So what actually happened is that here what is happening is the function is being called, and once the function is being called, these two parameters are basically going and assigning themselves to num1 and num2. It goes to this function here, and once it goes to this function, it basically returns the addition, and uh, the result of this addition is basically stored into sum, and that is outputted over here. So this is about functions. So moving on to our PPT, this is all about functions. Now we take up switch cases. So what is a switch case is, a switch case becomes very handy when we do not want to include multiple if else statements, which would become difficult in some cases, right? So when you include multiple if else cases, what happens is that in our code file, the readability of the code is slightly decreasing when you have multiple if else statements. So for again every if statement, if for the first if statement, you'll have to have a round braces, and then you might have to have the curly braces. Else if, again the round braces, if there is another condition inside that, you have to input that condition. There are so many braces now coming into play, and uh, so you might need to use so many of these braces in order to uh, you know work with it, and this will basically decrease the readability. Now the test value which we give pass to a switch case is generally an integer or it is a character. And the later points say that when the programmer writes one or two case statements, each of which specifies a value, and that value is basically tested and compared with the test value which we write in the beginning of the switch statement. We will look at switch statement in action also right now. So this is the switch.c. Now if I uncomment all these lines of code, if we were to use an if else block, what used to happen is we used to initialize an integer and we used to initialize a num, then that would be set to 9. And if the num double equal to 9, then there used to be a certain functionality which happens, that is over here we are going to basically print the value is 7. Else if num double equal to 8, this has to take place. Else if num is 9, this has to take place. And because we don't want to basically use these many if else blocks, we are basically writing it in a switch block.
Hello, Akash.
So so now what happens is that
What do it?
um,
No, I'm busy. I'm bloody busy now.
can you please mute yourself? Thank you. So now the number would be present here, and it basically goes to that particular case over here, and that whatever is being printed, that value is printed over here. So here what happens is that it directly, the control flow directly goes to case 9. We will anyhow be looking at this switch case by running this program also. So you just need to save the program and make switch as your startup project. And now when you run the program, we'll be able to look at the result. So the value of the number is 9. So this is what we exactly predicted before. So if we had written the same thing in if else statement, it could have become way bigger. And the other point is that if you want to exit the code in the case block, you just need to write the keyword break. So once you write the keyword break, it simply automatically comes out of the switch block, so switch case block. Now here this actually comes into play when you take up for example when you're implementing a data structure, for example in C. So every time you might need to perform a new operation. So on below the main function, it's much difficult to write so many if else blocks, and because of that, your length of the program also might increase. So an easy way in this situation is to incorporate a switch block over there. So when you put this switch block inside a loop, for example, you can keep typing those numbers in the keyboard, and whatever number you type, that is being taken, and easily once you are finished, and you can give for the default case, you can probably give, if you hit the number 0, then it has to basically come out of the switch the case block. And once it comes out of the switch case block, it is very easy to again rerun the program and retake the options that you want to. So that is about the switch statement. So I'll just wrap up with the switch statement. So this is just an alternative way to basically initialize and write the programs instead of using the multiple if else blocks. So moving on, this is one of the flowcharts that I had made for switch case statements. So at the top there is a single expression, and there are so many cases. Let us assume case 1, case 2, case 3, and to so up to so on case n. This uh, circle basically denotes up to so on, and we have the last case also, we have the case n. So here the comparison or the testing is basically done. So if the expression matches with case 1, it goes to the statement 1. Else if the expression matches with case 2, statement 2, whichever case it matches, it goes to that particular statement. And once the code block inside the case has been finished or compiled, it ends the switch. There can be sometimes when case 1 is not matching, case 2 is not matching, even case n is not matching, and in that kind of case what it does is it directly goes to the default statement. In the default statement, what we are writing is, if there is no match to any of these cases which are provided here, then you have to basically compile whatever or execute whatever instructions that are being given in the default block. So that is about the switch case. Now, modern C compilers have also come up with another interesting way of writing switch case statement, and that is by representing ranges in switch case statement. This means that from one particular alphabet to the other particular alphabet, there can be ranges. So if there is a switch statement, let us assume that that is a switch statement, and either the user can enter a capital letter or the user can enter a small letter. So if the user enters the capital letter, it enters into this switch statement. The input is taken from the keyboard, and the chart type variable, we have just probably might define a chart type variable, and it has to say whether it is an uppercase letter or a lowercase letter. So if the programmer types or the end user types capital A or small a, it goes to the respective cases. Now let's just imagine if these cases weren't there, then how many if else statements that we might need to use. If the character is double equal to A, then write uppercase letter. If it is B, then write uppercase letter. C, and so on up to Z, uppercase letter. So what happens is that we are writing set chart type is equal to uppercase letter probably so many times from A to Z, and the code readability is also gone because you have now so many if else statements for even the capital letters and small letters. So this is one major improvement, and modern C compilers let you to basically specify ranges, and the way in which the ranges are specified is by just typing these three dots. So if a match is made, when the switch test case matches any of the values in the start and end values of a particular range. So if it is capital A or capital Z or any other capital letter which is being input in the keyboard by the end user, it goes into this code block, else it goes into this code block. Once the chart type is being assigned the uppercase letter, the next line says that it has to break from this case statement. So the control flow does not be in this block anymore and simply comes out, exits this code block. So that's about the ranges in switch cases. Now moving on, we'll move on to loops. So in loops, basically what happens is that you might have a particular piece of code, or you might have a particular block of code that you want to keep on repeating for several times. So in such cases, what happens is that loops are very much required. Let us just consider modern application examples. So in an office scenario, what happens is that you might have even probably lakhs of lines of code that you want to write, and it is sometimes not that possible also for to sit down and write each and every loop, because if the same block of statement which we are going to write inside the loop block, if it is present for say 5,000 times in probably 1 lakh lines of code, then you're repeating the same thing again and again. So instead of that, you one thing what you could do is you could just write them in a loop, and this is the flow chart for a loop. So it tests a particular condition, and if the particular condition is true, it goes to the conditional code, and this code is being run inside the code block. And if the condition is false, it simply exits. We'll also be taking a look at each one of the loops by going to our Visual Studio. So this is the loops file, and I have commented. So the first snippet basically consists of line number 5 to line number 10. So if we uncomment this part of the loop, we see that the first one is a for loop. And we also know there are many kinds of loop that are possible. So one is for, the other one is while, and the other one is do while. These are the three types. And for example, when you take into consideration the for loop, inside this basically the arguments are specified. So int I is equal to 1 is specified here, semicolon. So this is the shorter range, and this is the high end, this is the lower end, and this is the higher end of the range. And in between, where you want to basically get the outputs, and this is the step value. So here it is just increasing by 1. You can also make it increasing by 2, or any other number for whichever you would want to. And inside the for block, a particular statement is written, which you need that particular statement to repeat for how many ever times you want. So that's why the lower range and the higher range are specified. So this is about the for block. When you just save it, you can even run this loop file. When you run this loop file, the for is basically executed, and as we correctly predicted, all the numbers are returned, that is 1 to 10 is returned. So from 1 it starts and it keeps on iterating, and every time it iterates it has to basically print that number. So as you can see, this is much more efficient than writing printf1, printf2, printf3, printf4 10 times. So this is about the first block of code. I've commented it because if we uncomment every piece of code, then so many outputs would display on the console window. So the best practice is to uh, uncomment each and every snippet in order to closely observe the values of the output of each of the snippet. So this is the second snippet. So here I'll be discussing about the while loops. So what happens is that before the while loop starts, we have an integer I, and that integer I is basically set to 0. And here is where the condition is checked. If the value of I is less than or equal to 0, it checks, and if it is true, it prints whatever code is there inside the curly braces block, or the code block. If it is false, then it simply exits the loop. And while writing, we also, it is very necessary to specify this I++, because if we don't specify this I++, what's going to happen is it's going to infinitely print the value of I. So that we do not want, and every time it prints, it's just going to be printing infinite times 0, because every time 0 is less than or equal to 10, and that condition is true. And when the condition inside this round braces is true, it simply goes to the code block inside and again prints the same number again and again. So we do not want that case. So that's why it's very important to keep in mind to basically specify I++ on line number 17. And now when you run this piece of code, you should be able to see the right output as we predicted. So 0 to 10 is the output that we were we wanted to get on the output screen, and the same thing can be done using a while loop or even a for loop. So that's about this code snippet. And in this code snippet, what we are going to do is we are actually discussing about the do while loop. So do while loop is basically, for the first time, it it says that you have to do, in the sense you have to basically execute the commands which are present inside this block, and afterwards at the end it basically checks for the condition. So this concept is the entry controlled and exit controlled. So these are entry control. So before even entering the loop, these are entry control, and it sees whether the entry is, if the entry matches or if the entries are satisfying these conditions, then it goes into the loop. Here, since it is an exit condition loop, so it checks for the condition after. So when we run this piece of code, the predicted output is being written on the terminal. So the same thing of printing from 0 to 10 is much more simpler in every of these cases, as we can see, than to initially type the number again and again. So I'll just run through these two snippets also. So in this snippet, what happens is that I is initialized to 0, and here there is the entry control condition which is being checked, and it checks whether the value of I is less than 10. Suppose the value of I is less than 10, it goes into the loop and it prints the value, and it goes back again to the while. Once the I plus plus operation is done, it goes back and checks again if the condition which we have entered is satisfied or not. Suppose if it is satisfied, it again enters. Suppose if it is not satisfied, it comes out of the loop. But here what happens is that here we are also checking if I double equal to 5. So if the value of I is assigned to the value of 5, what happens is that it breaks from the loop. So we are manually writing this break statement. We'll anyhow execute this also to see what exactly happens. Once it breaks, it comes out of the loop. That's the important point that we need to keep in mind. So just like any other C program, it starts with the hash include, and it also has the main function. And inside the main function block, we are writing all these snippets. Okay, so when you run the file, as you can see, 0, 1, 2, 3, 4 is only outputted, because once now the value of 5 has been assigned to the variable I, and when it has been assigned to the variable 5, this break statement causes the program flow to basically come out of this loop. So only 0, 1, 2, 3, 4 has been printed in that code snippet. And in this last code snippet, what we are doing is, it's a do while loop. Initially the variable I is set to 100, and since it is do, it basically enters this loop, and this is an exit control loop, so it checks for the condition at the end. There is a if statement also which is being written inside this do block, and it checks if the value of I is 15. If it is 115, then what happens is that it goes inside the if block, and I is equal to I plus 1. So basically the value of I is incremented, and then in the next statement continues written. That means that it says to continue this loop. So we'll just look at what's the output. So as you can see here, in the difference between this example and this example is, it stopped at 0, 1, 2, 3, 4. But here, except 115, all the other numbers have been printed. As you can see, after 114, it goes to 116, 117, 118, and 119. So except 115, all the other numbers have been printed. So this is the functionality of the do while loop, and this is the place where the continue keyword comes into play. So this is about continue, break, while, do while, and for. Moving on with the PPT. So I have basically made a flowchart about the different types of loops that are possible and what is the basic description of each and every of the loop. So the while loop repeats a statement while a given condition is true. For loops basically execute a sequence of statement or multiple statements which are present inside the block. And do while loop is basically condition is tested at the end of the loop body. So first in the do, we have those curly braces, it goes inside the program flow, goes inside, and after it basically executes the code which is present inside those curly brackets. When it exits the loop, it checks for the condition at the end of the loop body. And nested loops also is a concept where inside a for loop you can have another for loop. So nested for loops come into play when you're taking arrays, multiple multi-dimensional arrays. For example, when you're adding matrices, it's very useful in such cases. So these are the loop control statements that we just saw. We saw the use of break, we saw the use of continue, we also saw the there is another keyword called goto, and what goto does is it basically shifts the command to a particular label. It's very easy, but we will look at it in detail when we look at the flow chart of it. It's very easy when you see the flow chart. So this is the break statement flow chart. So in the break statement, what happens is that the test condition of the loop is tested. If it is true and if it encounters the break, it exits the loop. And if the test condition is only false, then also it exits the loop. Here, if the here break, when it goes to no, the remaining part of the remaining body of the loop is basically executed. That means, as we just saw in one of those examples, we have actually tested this and compiled it and got the output. So this is the continue statement flowchart. So in continue statement flowchart, what happens is the condition is basically tested. If the condition is tested and it happens to be true, it continues. If it is no, the code inside the body after continues. So once we come out of the continue in the this program, what we saw is, to understand better about continue, it basically says the program flow to still continue outside this block. So that's what is being written over here. Code inside body after the continue. So this is the code which is present inside the body after the continue. So this is being executed. That's what is being mentioned here. And initially, if the condition is false, as we know, it directly goes to the exit loop. So even initial, when the if suppose if it was 200 or 300 or something, then this while only would not work, but one time it would do because it is in a do loop. So as we mentioned, when we see the flow chart for goto, it's very simple. So there are three statements to be executed, and when the flows at statement 3, when it encounters a goto statement, and suppose the goto statement says that the program flow has to go to statement 1 due to some reason for the compilation of the entire application, the control flow just transfers itself into the statement 1. So this is about the go to statement. So now we'll be seeing the scope of variables. So scope of variables is a very important concept when you take into consideration, because the scope of a variable k is only within the main function here. So scope means that it basically defines the lifetime of a particular variable, where that variable can be accessed, whether it can be accessed inside a particular braces, or whether that particular variable can be accessed even outside that braces. So for example, when you take this code snippet, we can see that there is an integer called k which is being initialized here, and that value is being equal to 100. That value is being set to 100, and basically that value is being printed over here. And then there is a function called void p1, and here what happens is that the value of k is printed, but in this particular case, the value of k would not be printed because the scope of this variable k is only inside this function, and the scope of variable k is not basically present here. So you will not be able to access this particular variable k outside this function. So that's the meaning of this code snippet. And in the next slide, we have another code snippet, and here we'll be learning about the global scope. So here, when you see here, the integer k is basically initialized after hash include stdio.h. That means that it is not inside this main also, and it is not inside this void also. And this variable k now is having a global scope, which means that it can be accessed by any other function. So for example, p1, you can access this variable k. So when you printf the particular value, that is k, this 10 goes and prints itself, because this p1 function takes the value of the global variable and not the local variable. But here in main, when you can see, we have again reinitialized and a particular variable called k with the same name, and we have set it to be 3. Now in this printf, when you take into consideration, this printf would only take the, it would compare now, right, the whether it has to select k is equal to 3 or whether it has to select k is equal to 10. And the priority of local scope is slightly more than the higher scope, so the variable which is of higher scope. So in this case, what happens is that k, that is the value of 3, is printed, and local scope here is given more preference. And here the function call happens. So this is where the function p1 is basically called. So once the p1 function is called, what happens is that the control flow goes to void p1, and once it goes to void p1, when it executes this line of code, it basically takes this value from the global scope. So we do have a program that we have written in order to explain global scopes and local scopes. So this is the scopes.c file. So this is the first snippet that I wanted to show what we have discussed on the slide. So as you can see, there is a red underline under k, and when you see the error, it says identifier k is undefined. That means that it is not able to understand from where this k came. So since this is not accessible, since void p1 cannot access the variable which is present in the main function, it means that it cannot access it, and this is having only scope of this code block. So this value k is only accessible inside this code block, and its lifetime or its scope is not outside this main function. So that's about this program. When you're using an IDE, it's much easier to find out bugs, and you can easily debug all the code which is present. So over here, when you take up, this is the second snippet that I would want to introduce to you to explain the application of scopes. Here, when you take up, what happens is that int var is basically set to 3. And when you take it up, this variable is basically initialized before this curly braces. So the variable does not interfere, does not, this scope does not get into this block of functions. So when you print here, what it does is it takes the scope from here. But here again, when you see, this variable is reinitialized to 4, and in this case it takes the basically preference is given here to the local variable than to this global variable. So that's the reason here when you print the variable, 4 is the output over here, and when you printf the variable here, this again takes the preference of the global variable. So it takes this var is equal to 3, which is basically defined under the set of curly braces under the main. So that's about this piece of code. And the last piece of code is this. Again, this is the same thing that we have seen in the presentation. So this is the complete explanation as to the global and the local scope in the third snippet, what we have explained in the presentation. So here there is a variable called k, and it is being initialized to 10. So this is the variable with the global scope, as you can see. As we know that we have discussed that the program starts at main, so it starts at main, it gives k is equal to 3, and once it prints again, it's checking. So preference is given to local scope which is present inside this function block than the global variable which is present outside. So 3 is basically printed here, and when p1 is called, the program flow goes over here, and when the program flow goes over here, printf that particular variable is mentioned, and now 10 is fetched and it is being printed over here. So this is all about the local and global scope. So the presentation has concluded. Thank you so much.